So dividing complex just turns into multiplying complex, basically. So your first step is to identify that you can't have I in the denominator because it's a square root. And so in order to take care of that, we're going to take and we're going to multiply by the conjugate of the bottom, because it's the bottom we need to take care of. So when we multiply by the conjugate of the bottom, we're taking 4 plus I. See, the conjugate is when you switch what's in front of the I. So I was a minus, so now it's a plus. But if you remember your fraction work, whatever you do to one, you got to do the other, so we got to do that to the top also. So now we have to take and multiply this out, and we have to multiply this out. So that's 2 boxes. Okay, so we'll start with the top. And so if I set up the top, it's 2 plus 3i and 4 plus I. And I multiply those out. I've got 8 and 12i and 2i, and then we get 3i squared. And remember, I squared is -1, so we get -3. So now on the top, we get 8 minus 3 is 5, plus 12i plus 2i is 14i. So that's the top. On the bottom, we set up another box. And we have 4 minus I and 4 plus I. And yes, something special happens, but I want to make sure that you always write this out and do both, top and bottom, in boxes. And you'll notice that what happens is our imaginaries are going to cancel out. Let's see here, I got -I squared. This is a -1, so I end up with a negative times a -1. That's a +1. Okay, so if I look, the 4i and the -4i, they cancel out completely, and that'll happen every time. That's why we multiply by the conjugate. But we still do have our 2 real parts, and so we have to, that's why we use the boxes to figure out what those real parts are, and we get 17. Now in this case, this is our answer. There's nothing else I can do. Sometimes you end up with something like this, where you have numbers that can be canceled. See, if everything in our fraction can be canceled when we have a plus there, if everything can be canceled, we need to do that. So 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 4 twice, and so our final answer is 1 plus 2i over 2. That's for my imaginary one that I made up here on this side. But for our first problem, this is our answer.